So what we are going to do today, we are going to see two important things. First is what is media access control, and other is what are the various devices we use. What is media access control? What is happening? What we are going to see is some issue. We're going to see media access control, MAC, and then devices. So we'll be seeing layer 2 devices and later on layer 3 devices. Why the device can be considered as layer 2 or layer 3 or a passive or a active device, we'll be seeing in due course of time. Now, the most important aspect in network is media access control, and this is related with when you have shared media. Now, why we require shared media? First of all, let us discuss this. Now, if I say that there are 4 computers, suppose there are 4 computers and you want to interconnect them, you want to interconnect those 4 computers. अमरिंद अभी क्लास में है, ठीक है, फिर बात करते हैं. Now, how to interconnect those computers? That's the question. And I want that A, B, C, and D, 4 computers are there. So A can transfer to all B, C, and D. D can transfer to A, B, C, and hence on and henceforth. So how to interconnect them? That's the question. So that they can transfer data. You require media between these devices. You require transmission media between these devices. So how can we do that? Yeah, Abhiraj. Anybody else? Abhishek, Abhiraj, Aman,
Sir, we can
Anchal
link
Yadav.
them.
Can you speak loudly a bit?
Hello.
Yeah.
Sir, we can link them through wires. So to transfer any data from one to another.
So if I
Here we
say
can have
that
minimum 3.
I link
Yes.
like this,
Yes, sir.
then is it okay?
Yes, sir. If we don't make A to D, then it is again okay. Means
So
using
if
3
you want
wires,
to
we.
transfer to if you want to transfer to A to C, then this is also needed, or B to D,
Yes,
then
sir.
this is also needed.
Yes, sir.
So means if everybody wants to transfer to everybody, we require a kind of mesh. Yes or no? Yes or no?
Yes, sir.
Now, if you consider there are thousands of system or hundreds of system, means you are going to waste a lot of uh, wire, a lot of money to make them interconnected. So, and obviously not everybody will be transferring all the time. Not every pair would be having a conversation all the time. But still, if you want to transfer, say once in 24 hours, you have to have a wired connectivity. Suppose we consider the wired connectivity only. Now, this was the issue, and that's why this concept of shared media came into picture. Now, if I say that, let us put a long wire, or a bus, and if I connect A, B, C, D like this. So there is a long cable, and in that cable I have hooked A, B, C, and D. Now what's the problem here? Yes. What can be the issue here? I can't hear you properly. There is a lot of static noise. Anybody else can say? Yeah, Ishan Khan.
Yes, sir.
Anjali. Yeah, Ishan. So if I do like this, what can be the issue?
Sir, the sending data is received by the other end systems also. Like if I want to send from A to B, but it is also going to C and D.
So it will go to C and D also. So, but we have an IP address for that. Okay, even if it is going, I would be putting destination IP address of B. No.
Yes,
So
sir. Yes, sir.
other systems will discard that, and B will receive that. Yes.
Yes,
Yes,
sir.
sir.
So what is the other problem?
Sir,
Sir, if we want to
if
send,
there means if there somewhere is fault, then the next computers that will also face problem.
Okay, that is there. So you are saying that suppose the cable is broken from here. So that is here also. Okay. That is here also. If some of the cable is broken, then A and B are disconnected.
Yes, sir.
Any other?
sir, if we are sending from like B to C, then the pipe is already means full, so we cannot send concurrently from A to D.
Obviously. So let me state your statement in a different manner. Suppose A and B, A is transferring to B, and if the same time C started transferring to D, then there would be collision. There would be collision, and nobody will be able to receive anything. And that is the biggest issue in shared media networks. The problem of collision. If there is a same single bus or single channel on which nodes are connected, so at a time only one node can transfer. If two or more nodes started transferring at a given time, then there would be collision and nobody would be able to receive the data. That's the biggest problem. And to solve this, uh, there are many protocols which have been suggested, but the most popular protocol is Ethernet, both in wired and wireless. And obviously this is a data link layer job. This is a job of data link layer. Just a minute. This is a job of happening. This is a job of data link layer, and now this data link layer, which we have seen like application, network, sorry, application, then what? Then transport, then network layer, then data link layer, then physical layer. So this is data link layer, and now what we say that data link layer can be of two type. One is for point-to-point links, another is for shared links. And whenever we use shared media, we say that this is MAC sublayer of data link layer. So within data link layer, there is another sublayer. This is MAC sublayer. So this is data link layer job, and Ethernet is the most popular protocol and most widely adopted, both in wired and wireless. Later on, IEEE has provided standards for wired and wireless Ethernet. So for wired Ethernet, we have 802.3, and for wireless Ethernet, we have 802.11. This is our WLAN protocol, wireless LAN protocol. Fine. And this is our LAN protocol, wired LAN protocol. So these are the most common and popular standards which are there. Now, what is the problem and how Ethernet, wired Ethernet deals with that? Let us discuss that, and then only you will be able to know about the basic concept and the basic concept behind the MAC address and why MAC address came into picture. This is most important lecture because I'll be telling you two most important devices which are used in nowadays networks, and based on those devices our bigger network can be formed. So let us see here. Suppose I say that there is a long cable. I have seen these type of cable. I have worked upon these type of Ethernet where there used to be a STP, shielded twisted pair cable, the cable which you have seen in your cable network, television network. So there is a outer jacket, plastic jacket, and within that outer jacket there is a copper wire. Now in our time, as I'm telling about 96, 97, I went for training in a big industry where there I have seen this type of Ethernet, where this type of cable used to, go through the around the roof of a room, and then there used to be vampire taps. Why vampire? You'll be knowing this. So there used to be a needle-like connector. So you insert that needle-like connector so that it can touch to the internal copper wire. And with that needle-like connector, there used to be a transceiver. Transceiver is transmitter and receiver both. Transceiver, and then that transceiver is connected to our PC. Obviously the LAN card of the PC. So, and in this way all the systems are connected. So obviously the problem remains same. If one system is transmitting data, so that data is there on that channel. And at the same time, if any other system started transferring data, then there would be collision. Now, how the data is transmitted? Data would be following certain encoding mechanism. So if I say we are using binary encoding, then your data would be like, suppose this is 0 and this is 1, so it would be 0, 1, again 1, 0, 0, 1, 1, 0. In this way, data will be there. If it is using any other encoding, like if I say differential Manchester, then when there is a transition, then there would be a up to down kind of scenario when there is a transition. Fine. So depending upon the encoding technique, the data would be transferred. So how data is encoded, how the data is getting deciphered, which type of, because in any case we need to send data in form of voltage pulses. So in binary encoding, 0 volt is 0 and 5 volt is 1. In another encoding, voltage level may be same, but depending upon whether it is from 0 to 1 or 1 to 0, the voltage level may go up and down. That is data communication part. But the nutshell is that there is some encoding technique through which you can, using which you can transfer a stream of bits in form of some voltage level. And depending upon how the voltage level are changing, or how the data is getting transferred over the carrier, you can decipher that stream into a string of 0 and 1. Anyway, so the major thing is, suppose somebody is sending data bit by bit and at the same time somebody else started sending, then there would be collision. So after collision, whatever waveform or whatever signal form is there, it might not be the encoded form, and so nobody will be able to decipher the data. So what is Ethernet? Ethernet can be known in another term by CSMA CD. CSMA CD. Carrier sense multiple access with collision detect. Carrier sense multiple access with collision detect. So this is the technology on which Ethernet is based upon. Carrier sense multiple access with collision detect. So what is that? What is that carrier sense multiple access? Suppose there is a wire, a bus, and the topology I am drawing here is a bus topology. So I've just drawn a mesh topology to make you understand about the wastage of wire, and then this is bus topology. So what is happening here, before transferring any data, the system will sense the channel. Before any data can be transferred, system will sense the channel. If data is already available, system will not transfer anything. If channel is busy, and why the channel is busy? If somebody else is already transmitting data, then system will not transfer data. And it will try to sense. So periodically, almost continuously, every system is sensing the channel. Fine. Every system is sensing the channel. Why all the time they are sensing the channel? I'll tell you. Now, they will only transmit when channel is free. Can it avoid collisions? Suppose so what is media access control? What is media access control? Who can access the shared media? The control of that thing is media access control. So you require some arbitration logic. Suppose I say that the logic is very simple. Before transmitting, just sense the channel. If channel is busy, don't transmit. Wait for channel to become free. And when channel is free, transmit. Can it avoid collisions? Anybody? Can this particular schematic or this particular procedure avoid collisions?
No, sir. So if the channel is empty at some point, but the wire is long, then there are chances of collision.
Obviously, if suppose channel is free and two systems, say A and B, both find that channel is free and they at the same time started transmitting the data, there would be collision. So Tanmay is right. So maybe it can reduce the number of collision, but we cannot avoid the collision. So collision can still be there. So what is happening? Now, if I ask you a question, and I'll give marks on that if somebody can answer. Suppose you have started transmitting data. After how long, after how much time you can be really sure that you have acquired the channel? Suppose you have found the channel free and you have started transmitting data. After how much time you can be really sure that now the channel is yours? You have acquired the channel. Anybody can make a guess?
सर ट्वाइस आप सर जहाँ भी सेंड करना है वहाँ पहुँचने का जो टाइम है उससे ट्वाइस टाइम
उससे ट्वाइस टाइम जहां भी सेंड करना है उससे क्या मतलब है?
सर जो एक्नॉलेजमेंट गेन करने के बाद सर एक्नॉलेजमेंट गेन करने तक
So there is no question of acknowledgement here. Fine, we are at lower layer. Fine. Now I'll tell you. So suppose you have started transmitting. So your data bit will take some time to reach to the end of the cable. Fine. Suppose there are two farthest systems are there, say system S and system T. These are the two systems, farthest system, and means they are at the edge of the wire. So it will take some time for this bit, first bit to travel to T. Suppose this time is tau. So if for this tau time you don't hear any collision, fine, because while you have transferred you are sensing the channel also. For this tau time, if you don't hear any collision, it means everybody has known that you are transferring data and now everybody else will not transfer. Because before transferring they will sense the channel. Am I right? Suppose I say that
Yes.
from S to T, it will take tau time. Let there be a length of wire, say 100 meter, and the propagation speed is 2 into 10 power 8 meter per second. So it will take some microseconds or milliseconds to reach this data from one end to another end. So if this time is tau, and for after transferring the first bit, you don't hear any collision, you don't hear, because you are sensing the channel for collisions also, you are continuously sensing the channel. If you don't hear any collision for tau time, then it means everybody has, because everybody else is also sensing the channel, everybody knows that you are transferring and now you have acquired the channel. Yes or no?
Yes, sir.
Yes? Yes, anybody else?
Yes, sir.
Sure. Okay, if you are sure, then suppose I say that just before data from S has reached here, just before T sensed the channel, T found that channel is free because data from S hasn't reached up to T. Fine. T started transferring and there is a collision. Now this collision will also take tau time to reach to the S? Yes or no? So if I say that if we don't hear the collision for 2 tau time, then only we'll be very sure that there is not going to be any more collision and we have acquired the channel. Now what say, Tanmay?
So the first time around, before tau was completed, T is checking, right?
Yeah. Just before Miss Tau is about to complete, and so the collision will also take near about tau time, no?
Yes, sir. Yes, sir.
To reach to S, no? So we need to wait for 2 tau time just to make sure that we have acquired the channel and we can start transferring with full throttle.
Yes, sir.
Clear to everybody? Anchal Tiwari, clear?
Yes, sir.
Anubhav Mishra, Anukul,
सर एक बार रिपीट कर दीजिए
क्या रिपीट करना है बताओ?
सर ये टाउ टाइम सर ये जो मतलब सर
Suppose it takes tau time from here to here, end to end. Fine. And an end system has transmitted data. So this data will take tau time to reach to the next end. Just before the next end, somebody else at this end started transferring data. There would be a collision.
yes
Now,
sir.
now there is a collision. It will be known to this system after tau time. So you have to wait for almost 2 tau time to make sure, to be really sure that there would be no collision now in my data transfer, because everybody has known that I am transferring, and for 2 tau time there is no collision. Fine? Is it okay?
Yes sir.
Sir, will it not be like when T sends some signal? So before reaching S, the collision will reach to T. So will T not get back out? Like before reaching the like the signal to S, the signal will reach T because it is near T. So in that time, T will get to know that I am not able to acquire the channel. So eventually T will back. So I think S will acquire the channel.
तो S भी तो खत्म हो गया ना, डेटा तो गया ना, कोलिजन हो गया.
So sir, after like who will acquire it?
That's the question. First of all, right now the question is different. When the question is when you will be very sure that you have indeed acquired the channel. First of all, let's stick to that. Who will acquire? That's a different story.
Okay, sir.
In
Like
case of-
I'm saying that if S sends some random data just to check that whether he acquired the channel or not, and before reaching T, just before T sends some data. So before eventually the signal that S get to know that I am not able to acquire the channel, before that T will get to know that it acquired the channel. Yeah, that data that S actually send for testing, that was exhausted, that no one able to send that data. But after that T will back out, that T get to know that T will not send any further data. Now
why
S
T will
will free
back
to
out?
send.
Why T will back out? Why not
because-
S back out?
So because before S, T will get to know that there is some collision, because the data that the bit is near T, so the
Pay
collision will
attention to
happen.
this. Pay attention to this.
Okay, sir.
Now you got the point?
Yes, sir.
It is not seconds which are happening in between, no? And first of all, the thing is, look, you are thinking T will know the collision has happened. Okay, so T will back out. But because T was also sender. Why not S back out? Why you are giving what to say, punishment to T? Because both S and T are culprit, yes or no?
Yes, sir.
But T is near to collision, that's why you are saying that T is a culprit. What T has done wrong? T has also sensed the channel, find the channel free, started transmitting. It resulted in collision, that's a different story.
But sir, like we have to like only allow only one signal. Like if we allow T,
So,
then S will not be allowed.
I wanted to have this upper limit, or rather, at least 2 tau time. Fine. And
Okay,
if
sir.
2 tau time is there is no collision, at least 2 tau time, if there is no collision, then S can consider that I have acquired the channel. Is it true or not, first of all?
Yes, sir.
That's okay. Now let me come to the collision thing. Okay. Now what is happening with collision is a transient signal. It is kind of a spike. It's like normal data is transferring, normal encoding is there, and then suddenly there is a spike. Transient signal means it stays for very less duration. So not everybody on the channel may be able to know that something has happened. Forget about near or far. Fine. So only the system which is near to the collision will be able to know that collision has occurred. And that system which is near to the place of collision may not be sender or receiver. Yes or no? So suppose this is a channel. So these are the nodes which are connected. So suppose this node S is transferring to T. So right now S is sender and T is receiver, and collision occurred at this place. All the other nodes are also listening. So whomsoever who is near to this collision place will be able to, because everybody is listening, will be able to know that there is a collision. So whomsoever knows about collision will send a specially encoded jamming signal on the channel that why there is a collision. Especially encoded jamming signal telling that collision has happened. This will be sent by the node who has got to know that there is a collision. It may not be sender or receiver. So that spatial jamming signal will be traveling. You may ask me questions that this jamming signal again can get collide. Yes, that somebody is sending jamming signal, somebody else may send data, and then they again can collide. So somebody else will send the jamming signal. That is going to be there. Now, after jamming signal is available on the channel and everybody come to know that there is a collision, there may be more than one culprit. In this case, we have S and T, because both have started transmitting at the same time. So here in our example, what example we have taken, S has started transmitting, after some time T has also started transmitting, there was a collision. Somebody who listened to the collision has transferred the jamming signal on the channel. Both S and T now know that यार हम ही लोग भेज रहे थे, due to T will think यार मेरे भेजने से collision हुआ, S will think यार मेरे भेजने से collision हुआ. Now what will you do? Now there would be binary exponential back off. Now pay attention to me. What is binary exponential back off? So there is a window of some numbers, say from 0 to 8, 7. So both S and T, because they think they are culprit, will take any number, random number from this window. S will take something else. T will take, most likely they will take different numbers. Suppose S has taken 4 and T has taken 7. Now S will start trying to send data after 4 into some unit time, sometime, and T will start thinking about next trial after 7 into some unit time. More detail I'll cover later on. I'm just telling you the hint. Now, why this has been done? Because after jamming signal, both may again try and then again result into collision. So we have to come up to a policy which can avoid collision as much as possible. You cannot completely abolish the collision on shared media. That is not possible. But you need to just lower down the probability of collisions happening. Now, this is how collisions are going to be avoided. Everybody will listen to the channel. If channel is free, they'll transfer the packet. If there is a collision, they'll back off. They'll back off, and a special name is binary exponential back off. Next time, suppose S started transferring, and again it resulted into collision, the window of S will be increased from 0 to 7 to 0 to 15. And now S will choose number from here. That's why it is known as binary exponential back off. So obviously you'll be taking, I'm not telling you exactly what is happening in Ethernet. I'm telling you one of the arbitration technique. What is happening in 802.3 in Ethernet, really we'll be dealing this in data link layer. I'm just telling you the procedures, various kind of procedures which can be applied to arbitrate the channel so that there would be less number of or less probability of collisions. So this is how the things are getting done to avoid the collision in shared wired media. Now let me come to another important point. Suppose there is a shared bus and there are nodes which are connected up to this bus. So A, B, C, D, E, F, G, H. These nodes are there. Now A wants to transfer data to, suppose A wants to transfer data to D. So A will put source IP as its own IP and destination IP as D's IP. You need to provide identifier where you want to transfer data. Now when A transfers data, this data will be heard by E, B, F, C, G, H and all. Everybody will be receiving this packet, this data. Everybody will receive. Everybody will open the IP header. Every node will open the IP header. and then will compare the destination IP address with their own IP address. If there is no match, the packet will be discarded. So only everybody will accept the packet. Everybody will accept the packet, but only D will accept the packet and receive the packet, because D's IP address will match with the IP address which is in the destination IP address field of IP header. Now, what was the issue here? That is where we need to focus upon. Just think over it, whatever I have told, for 2-3 minutes, and then if you are having any issues, you can ask. So I'm giving you 2-3 minutes to think over this particular scenario. Yes. Anybody is finding any issue here? Yes, Tanmay, Ishan.
So I don't know, sir.
No, sir.
Things are logical or not? It is there on the channel. If it is not matching with my IP address, it means it is not meant for me. Now the problem here is, what was the problem? Just please be with me. What was the problem? Network layer is implemented in network operating system, means inside the kernel. So for every damn packet which is on the channel, all the nodes have to receive this packet, accept this packet, disturb their kernel, means they need to send this packet to a kernel routine, and then match with the IP address. They cannot quickly take decision to discard the packet. And that was eating the CPU cycle. That may eat CPU cycle, because at one point of time, if there are large number of packets which is getting transferred between A and D, you are unnecessarily wasting your CPU cycles, because every time you are disturbing your kernel and using a routine and matching with the IP address. And due to this issue, here comes the concept of MAC address. Media access control address. For shared media, in addition to IP address, we need to have one more address known as MAC address. Media access control address. And this media access control address will not be the part of kernel. That is the part of a peripheral device, which is your network interface card, or popularly known as LAN card. So when you purchase a PC, there is a LAN card. If you are purchasing a laptop, there would be a wireless LAN card and a wired LAN card. and your MAC address is fused into it in a ROM. So MAC address is of 48 bits. Out of 48 bits, 24 bits are provided by are for the organization identification who is manufacturing this MAC address, and rest 24 addresses are for the how many MAC LAN card they are producing. Now LAN card is a peripheral device. Now what is going to happen now that on a channel, if you see a LAN card is having a ROM, a little bit of RAM, and now this LAN card are having a IO processors also and something like that. So they are having one algorithm which is running. So this CSMA CD algorithm is running on the LAN card. So if somebody asks you a question where this data link layer and physical layer is implemented in your PC, so data link layer and physical layer is implemented in the LAN card. If you have an optical fiber connection, you have a different LAN card, where physical layer is converting optical bits, optical values, LED values into bits, and then depending upon which protocol is getting utilized, that protocol or algorithm is implemented in the LAN card. Now what will happen if we have another concept? First thing, we can put destination MAC and source MAC addresses in Ethernet frame, data link layer frame, data link layer header, which is the outermost header. When a packet comes out, the packet starts from data, then application header, then transport header, then network header. This is how the encapsulation is. Data is encapsulated by application header, which is encapsulated by transport layer header, which is encapsulated by network layer header, which is encapsulated by data link layer header. And in this data link layer header, we can have source MAC and destination MAC. So when the packet is out, this is the outermost header. Now these nodes which are connected to this bus are not required to open the packet up to the network header. So this peripheral device, which is LAN card, can just accept the packet and just see the destination MAC address on the data link layer header or a MAC header of that packet, and will compare with its own MAC address, and if it is not matching, discard. So you are not going to disturb your kernel and hence CPU cycle and all that. The LAN card level decision can be taken whether this packet belongs to me or not. And that's why this MAC address came into picture. So your machine is having two identification. One is logical identification. When you come with your laptop in our institute, you change your IP address. You go to airport, you get different IP address. So IP address is a logical thing which can be changed depending upon which network you are in. But MAC address is physical address which is fused in your LAN card. And why MAC address is needed, now you know about the things. Any questions at this moment?
So are we still sending the IP address along with the MAC address?
Yes, obviously. They're part of standard.
Okay, sir.
You cannot, remove the standards. whatever advancement you need to do, you need to be backward compatible. That's a rule in technology. Okay?
Yes, sir.
Any other question?
So I want to ask one question.
Yeah.
Also, let's say in talking about the comparison thing, we are not making any kernel call, but still some code or something need to be run to compare that MAC address.
That is running in the IO processor of LAN card.
Okay, sir.
माइक्रो प्रोग्रामिंग पढ़ा है कभी? इसीलिए कहते हैं
हाँ,
आर्किटेक्चर
इस
अच्छे
सेमेस्टर
से आना
में है।
चाहिए.
इस सेमेस्टर में है सर.
It's an embedded, no? Embedded thing. Fine. So the algorithm is running there. And to match the MAC address is very simple. You can have a small micro program which can actually a register where the incoming MAC address can be loaded and a register where a existing MAC address can be there, and you can do a comparison in 1 or 2 cycle. Yes or no? Okay?
Yes, sir, got it.
Now, let's come back to our original issue today, original agenda of today, that is devices and types of devices. So, we'll start with a very normal device that is known as repeater. And if you take example of copper, after 90 meters to 100 meter, whatever signal you have transferred, that signal start getting attenuated. Means it is hard to decipher whether it was 0 volt or 5 volt. This is the property of the material. So now what you do after every 90 meter, you put a physical layer or a passive device which enhances the signal value. So a 90 meter cable, a repeater, and then again a cable. So it can, this signal can again be alive for next 90 meter, again one repeater. So it takes the data at one port, enhances the signal strength, and then transfer to the next port. These were very common, and these are very common when you see your cable television network. You might have seen device which they say booster, signal booster, and they connect the signal booster after every say 20 houses so that their cable signal strength can be up to the mark. So initially, when we have bus-based systems in a building or in a campus, we used to have this coaxial cable running, and every 90 meter we used to have a repeater so that it can run for next 90 meters. These are very old days I'm telling you about. I'm telling you about early 90s, late 80s. Now next come the device which is known as hub. Hub is nothing but a multi-port repeater. Just instead of a cable and then a repeater, hub is a multi-port repeater. That whatever you take from one port, the signal will be enhanced and it will be forwarded to all the ports. So why hub? Hub is a networking device. Why it came into picture? Just to have a star or ring. Oh, sorry, not ring. Just to have star or tree topology. Means this was the bus topology and you wanted to have star or tree topology. So you can have, suppose you want to connect 8 systems together. So either you have a bus going and you connect 8 systems like this, or you can purchase a hub and you can connect 8 systems like this. This came into picture because of Cat5 and Cat6 cabling standard, which was unshielded twisted pair cables, which we use till date in networking. You might have seen that there is a LAN connection port where you insert RJ45 jack. It's just like this, and the cable. So these are having these type of connectors, and you insert that. You have 4 pair of wire, 4 wire pair, and these are twisted pair cables. Why twisted? Because that's electronic thing. When you have a current flowing in a straight wire, that convert into RC coupled circuit, which is nothing but an antenna, and you have a magnetic field around it. So just to cut off these things, we twist these pairs so that it is not straight anymore, and just untwist and punch into an RJ45 jack, which can be inserted into your computer. So for networking, for star or a tree kind of topology, hub came into picture. Quality wise, property wise, it is just as good as bus, because here also if A is transferring data to B, so the data from A to B will be going, but it is going to all other devices also. What hub is doing, hub will take the signal, strengthen the signal, and just forward it to all the nodes. It means the data of A can collide with anybody else. Here also data of A can collide with anybody else. So property wise, hub and bus are same, just topology is changing. Hub is also repeating the signal. It is just a multi-port repeater, you can say. It is just a multi-port repeater. Now, if I ask you a question, let me draw a topology, and then let me ask you a question. Suppose I say that there is a hub 1 which is connected to, say, hub 2, and here there are 4 nodes, A, B, C, and D. E, F, G, and H. And now suppose A wants to transfer data to, say, D. Suppose A wants to transfer data to D. With this data transfer can have collision with how many nodes? Suppose A wants to transfer data to D, this can collide with data of how many nodes? Yes? Anybody?
So 7, all other.
4.
All other nodes. All other
4.
nodes. No, not 4, bacha. Because suppose A is transferring data to hub. Hub will send it to here, 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 here. Once it reaches here, 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 and here. So when A is transferring data to D, all other nodes are potentially in a what should I say, one collision domain. All 8 nodes are in one collision domain. Now, if you keep on increasing hubs like this, like one hub, you want to have a tree type of topology, another hub, you want to connect more systems, and so there is a limit of how many hubs, how many passive devices you can have. Because if the collision domain is big, at one point of time there would be only collisions, because you can only reduce the probability of collision. You cannot abolish the collisions altogether. And that was the biggest issues in designing LANs, local area networks. Then they thought about another option. Hubs are not used nowadays. Passive hubs are not used nowadays. Now, what they thought that let us think about an active device. And that active device was first of all called as bridge. It's a generic name. Now, if I have a bridge here and then I connect same topology, H1, hub 1, hub 2, and now I connect my nodes A, B, C, and D, E, F, G, and H. Now, bridge is an active device which is having its own RAM, algorithm, bit of secondary memory, everything is there, algorithm and small operating system, everything is there. Now, bridge is having 2 ports, 1 and 2 right now. And then bridge is connected to one hub. Here port number 2 is also connected to another hub. Now, this bridge can be configured. This bridge can be configured. How they can be configured? This bridge is having a table. That port number 1 of bridge is connected to which MAC addresses? MAC address of A, MAC of B, MAC of C, and MAC of D. Obviously, port number 2 is configured that okay, port number 2 is connected to MAC of E, F, G, and H. Now, this table is there. Now, let's take the same example again. A is transferring to D. So, A will send packet to H. H will transfer it to B, to C, to D. But H will transfer here also because hub is just repeating to all the ports. Hub will transfer it to B also. B will store the packet, will open the outermost header, Ethernet header or MAC header, will see source MAC and destination MAC. Okay, destination MAC, because A wanted to transfer to D, the destination MAC would be of MAC of D. B will inquiries table. Okay, and source MAC is MAC of A. Okay, source MAC and destination MAC both are connected to port number 1. Bridge will not forward the data further if A is transferred to D. Bridge will only transfer the data further when source MAC and destination MAC are on different ports. Now, what it does, it has broken the previous collision domain into two collision domains. Means if I want to transfer data this side only, then my data can collide with these nodes. If I want to transfer data this side only, then my data can collide with this side nodes only. So the whole collision domain is broken into two parts. So this was the initiation of store and forward devices which are active, which are taking decision based on some addresses, and they are taking decision based on MAC address, and that's why we'll say that bridge is a layer 2 device, because it is taking decision. It's an active device, store and forward device, which is taking decision based on layer 2 address, MAC address, and that's why it is known as layer 2 device. And now easily we can see that collision domain is broken into two parts. Any doubts to anybody? Okay, if there are no doubts, then we can stop here. Fine. We can stop here, and on the next turn we'll further this discussion and we'll tell you about some more devices. Fine. And let's see. If there are no questions, then we can leave. Thank you.
So
Yeah.
So let's say the EFGH, I am considering that they are like the LAN cable to different rooms of a hostel.